Hello, everyone. I'm going to review the reverse engineering PowerPoint so that you have the notes on that. This is what we would have gone over in class. So let's begin. We are in the reverse engineering phase of our project. You've already done the visual analysis. We're about to do the functional analysis. So this is a what is reverse engineering? And that's where we take something apart to see how it works in detail. There are a couple of things that we really want to understand with reverse engineering: structure, function, and operation. So there's a number of reasons that we do reverse engineering. Maybe you need to document a project. Maybe you need to discover more about how the product works. You're looking for a specific function. Maybe you need to investigate it. Maybe you just need to make it better. So something's breaking, you reverse engineer it, find out what's causing the failures, and make it better. Some more examples here. Maybe a product doesn't have existing documentation, or maybe you need maintenance, so you reverse engineer it. We have our notes down here. The product has been lost. Maybe it needs to go to a computer 3D model. It's essential to understand the function of a system. So integrated circuits, think about circuit boards, often designed on obsolete or old systems. So if they want to be used in a new device, we have to have some type of reverse engineering, as well as helping us do routine maintenance, repair, that type of thing. Systems need detailed documentation. We do discovery for academic research, learning, or curiosity. The Human Genome Project, where we mapped the DNA and genomes, that is reverse engineering. All right. Reverse engineering the brain is one of the grand challenges, for engineering. We want to be able to decode and simulate the cortex of the brain. All right. So that's another reason to reverse engineer. Maybe it's discovery or curiosity. Military and commercial intelligence is a huge use of reverse engineering. That's why if any US aircraft, any top secret thing crashes in another country, it is a huge deal because people can identify components, functions, and operation of new technologies. So here's an example here. Soviet engineers wanted to recreate an exact replica of the B-29 bomber, but there were things that were changed, tried to make better, but at the same time, you can see here a small hole mistakenly drilled was reproduced in every Soviet bomber. If we want to use it for investigation, we need to document patent infringement or find out where design failure was, analysis and testing. Reverse engineering can help verify patent infringement because it can see, hey, did they use a patented process? Okay. It's used to improve or redesign a product, efficiency, reliability, manufacturing techniques, maybe reduce the cost, all types of reasons. You can read them all here. It can help us correct mistakes made by previous designers. Okay, and that's kind of the incremental improvement here. Think about reusing your science fair project if you did an engineer style one year after year. A lot of what you're doing is improving or redesigning a product, and it's a perfectly valid thing to do. So here's some of the tools that can help reverse engineering. Micrometers, which is the small scale caliper. Dial calipers, which we have used. This is a digital version. Optical probes, there's medical imaging software, and there's 3D laser scanners. Okay. So here's our 3 stages. Visual analysis, that's what you've already done. Functional analysis, what we're about to do, and then structural analysis. The functional analysis is non-destructive. That's the first key. We are not taking the product apart yet. The 3 things that we need to do is identify what is the purpose of the product, what observations can we record to see how the product functions, and what inputs are required for the product to output its desired function. Here's a toothbrush example. The purpose of this toothbrush is to clean teeth and gums. All right. Here's all the ways it works. Water and cleaning paste are used in conjunction with the brush. So it's just identifying the main purpose of your product. The function. Now notice that we would have done an annotated sketch, but we are just going to take pictures and type some stuff instead. But what we're doing is looking at all the components that we can see, and we're going to try to describe in detail the steps or function, the sequential operation to make the device work. That's done through what's called a black box systems model. So we identify what goes into the product and then what comes out of the product to make it work as a system. This black box represents all the internal components or processes which are unknown at this point. So we might not know the inner workings of that toothbrush, and that's represented by this black box. So here's our functional analysis example. The things that are input or used with this toothbrush to make it work. Hand motion, right? You got to move your hands to brush your teeth. You need to input toothpaste. You need to input water, unless you're one of those people that brush your teeth without any water at all, but I don't really know what to tell you then. And energy coming from the battery. Then toothbrush works. That's product function. That's interior function. We're not getting to that. The output, after we've put these in, the output is sound, because you can hear an electric toothbrush buzzing. Heat. Heat is always an output of a mechanical system. Waste, you can think of the toothpaste and all that you spit out. And then clean teeth and gums, the purpose of this product. So that is the basics of our reverse engineering PowerPoint.